All right, so this is Mr. Royks. We're gonna take you through the last two problems on the dimensional analysis worksheet that I assigned for homework. Question number 4 was determining the amount of, or determining the mass of air pollution over Denver. And it said basically that if you looked at the total volume of air over Denver, we have 1.5 e to the 12th cubic feet. And they also give us a density of the air pollution as 1.1 e to the negative 5th grams per liter. So in order to be able to get to mass and be able to solve for grams, we need to convert this to liters, the volume to liters. So we're going to work through this process. It's going to be several steps, but I think if you follow along, you should be all set. So first thing is, obviously we have feet, and 1 foot is 12 inches. But if you look here, this is feet cubed, and so what we need to do is we need to cube these values. So you're cubing 12. Then the next step is we're going to go to centimeters, and we can say 1 inch is 2.54 centimeters. Actually, sorry, I missed the centimeters there. So there's your centimeters, and just like we did with the previous one, and I forgot to put the cube sign here, I'm missing things all over the place, we need to cube these values in order for them to cancel. So that allows for the inches cubed here to be canceled by the inches cubed here. Then the next step is going to be converting from centimeters cubed to milliliters. So we can say there is 1 centimeter cubed in 1 milliliter. And then we need to get to liters, so there is 1 liter in 1,000 milliliters. Alright, I'm running short on room here. But what we're going to do next, see if I can move this over a little bit. Sorry, I'm losing the half here. But then what we want to do is, our last box is, now that we have it in liters, we can use this density that we have up top here, and we can say there are 1.1 e to the negative 5th, and that's grams per 1 liter. So, I think I'm done here, and let me just confirm that by canceling labels. Cubic feet are canceled by cubic feet. Cubic inches will be canceled by cubic inches. Cubic centimeters will be canceled by cubic centimeters. Milliliters will cancel milliliters. Liters cancel liters. And our answer will be in grams. And the math on this, if we do this correctly, we should end up with a mass of 4.7 e to the 8th grams. Alright, so that's that problem. That's 4. And we're going to do the last problem now is 5. Alright, so let me just delete this. Alright, so problem 5 is referring to bromine being removed from the oceans, and we start off with the volume of the ocean, or the mass of the ocean being 1.3 e to the 21st kilograms, which is a massive amount. That's well, I almost said it was a ton of water. It's a lot more than a ton. And so that's kilograms of seawater, H2O. And so what we want to do is we want to figure out how much bromine there is in 1 kilogram of seawater. So we're told that seawater contains 0.006% bromine. So if we're using it as a decimal and we're saying there is 1 kilogram of seawater, then in decimal form there would be 6e to the fifth, negative fifth, kilograms of bromine. So now we have that. And since the value were the information we're given that we're going to use, a conversion factor, is there are 5e to the fifth tons removed per year. So we want to work our way so that we get down to, tons. So we want to go from kilograms to tons. So we need to go from kilograms to pounds. So we can say in 1 kilogram there is 2.2 pounds. And then the conversion factor to tons is there are 2,000 pounds per 1 ton. And now we can use the factor that's given here, and we can say that for 1e to the fifth tons, it would take 1 year. And that would give us a time format, which we're trying to answer in. Double check our labels. Kilograms of water cancels kilograms of seawater. Kilograms of bromine cancel kilograms of bromine. Pounds of bromine cancel pounds of bromine. Tons of bromine cancel tons of bromine. And our answer should be in years. And if we do that correctly, we should end up with an answer of 8.6. And this is based on sig figs. Two sig figs in this first answer here. 8.6 e to the 8th years. All right. Hopefully this helped you. These 2 videos kind of helped you work through tonight's homework, and you're getting a little more, building up a little more confidence with your dimensional analysis. All right, we'll see you in class.